Well, welcome everybody. Hope you are doing really well. Has been like very interesting weeks on crypto and a lot of improvements on aimbot side because I just added a new feature to the MCP repo to manage multiple servers. Now you can connect multiple servers in with the same MCP. Today we're going to cover a full pipeline of how to download market data, generate features, and then use those features to deploy new bots. This is the repo of Quants-Lab. Basically, on the last release, I removed the Postgres database. The reason why I was using a Postgres was to store the candles and the trades. Packet files for candles will be faster to load all the candles. Usually, we are using this for research. This config is probably one of the most important things that you are going to use. Here's how you define in this YAML the tasks that you would like to run. In the templates, you will see that there are like a mix between tasks that are actually Python files that inherit from the task base. So if we go here to this candles downloader, you see that this is a base task and it has an init, you can pass a config, it has a setup, and the most important method is execute. That is a method that will be executed when the bot is like running, where the task runner is checking the tasks that it needs to run. When it says, okay, it's time to run this candles downloader task, we'll execute this task, okay? How it knows when it has to execute it? Because it has a schedule in the YAML. You put a schedule saying with a frequency of every 6 hours, run this task. You can also add dependencies. This is like really interesting because you can concatenate one task with the other. For example, here in this one candles optimization task, it has this candles downloader that runs every 6 hours. So this is the first task, and the second task is the MACD optimization. That basically this notebook tests the MACD indicator with that strategy with different parameters. But as you can see, the schedule is not appearing here because it has these dependencies. So what it will do is it will run this task after candles downloader finish, so it's on completion, with a delay of 5 minutes. So basically it will download the candles, wait 5 minutes, and then run the optimization task. So these are like some improvements on the original task feature that we have. The good thing about this is as well that once you define the task in this way, you can just go here and run this name of the YAML, and this will start a Docker container that will run forever with the schedule that you define. So it's really powerful. Here we have like a very easy way to run tasks like downloading data, generating features, making screeners. It has the orchestration of Jupyter notebooks. The main difference between this declaration of how to run tasks and this one is that in task class, we just need to put notebook here. The frequency, the schedule can be like this, run this every half an hour, or you can also use cron, and here you can put cron, and it will run like a kind of cron job. So I added support to frequency in hours, and I also added support to deploy it as a cron job. And basically what is going to do this, to run in a sequential way, these notebooks that are download candles, trend following grid, like this will be adding features, and then doing the orchestration of the trend following pipeline that we're going to cover each notebook independently right now. These save outputs, you can put it as true or as false, but what it will do is inside here, app outputs, you will see that it will create a folder with the output of the notebook run. So you can see actually what is the output that the notebook had at the time that it run. So we're going to cover all that today. And also the execution sequential says that it will run one notebook after the other. What if I want to separate and say, okay, the TF pipeline should run with another schedule, like we should run this one every hour? In this case, it's also very simple because we can just go here and say orchestration config notebooks. We just put this path here. This is going to be one task, and we should remove this from here. This is going to be one task that will run these two notebooks every half an hour, every 30 minutes, and this will be another task that will be running this notebook every 24 hours. So basically, and this is like inside a Docker container. You can create multiple YAMLs, and using the make run tasks with a different config, you will spawn another container for each of the tasks that you are going to be deploying. But well, let's first understand the structure of the notebooks to understand what they are doing. So the first one is this one: download candles all pairs from data collection. So we go here to research notebooks, data collection, download candles all pairs. So as you can see, here you have an explanation. Important notes on rate limiting. This is probably the most important thing. And actually yesterday I was banned from Binance because I was running this in the same server that I was trading with 10 bots. Be careful with this. Mainly because the first problem that we have here is that the candles are not sharing the same throttler. Like each candle has an independent throttler. That is something that is in the queue to improve. If you don't want to have problems, you can reduce this batch candles request to have like 5 candles at a time. If you are confident that your bot that you are going to request a few candles, you can just put like here like 20, for example. If I run this, what I'm doing here, just to explain you, I am setting up the connector name Binance Perpetual. The interval 1 minute, I will collect 7 days, and I will get the last 20 days, 20 candles per batch, and I will sleep 10 seconds between each batch. So the first step here gets the trading rules for a connector. Let me put a break here so you can understand what is these trading rules in case that you are new to Hummingbot. If I check the trading rules here, is this trading rules data structure. If I access to the data, it gives me the trading rules. If I access to associated trading rule, it tells me this is a trading rule for Bitcoin USDT on Binance Perpetual. It tells me the mean order size, the mean price increment, the mean base amount increment, the mean quote amount increment, the mean notional size. This means that in order to place a trade on Bitcoin, I need to put at least $100. And we can cross-check with the UI. If I go here, I want to put a loan for $50. See that says minimum quantity is 107 and 7. Why 107? Because I have 2 restrictions here. One restriction is the mean notional that says minimum $100. And the second restriction is mean order size of 0.01. So this is 0.01 Bitcoin. If we do 0.001 Bitcoin times 107K is $107. So well, these are the trading rules basically. So what we can do with this trading rules object that we just get from in Quants-Lab, we can say trading rules that get all trading pairs, and here we can get all the trading pairs. Or we can do, for example, dot filter by quote asset, and I can just say give me only the ones that are quoted on USDT. And I can also filter by mean notional size, and I can say I want to trade only the ones that are below $10. So here I should not see Bitcoin. This is what you can do with the trading rules stuff. So coming back, why I'm explaining this, because this notebook that is called download candles all pairs, what it's going to do is to get the trading rules, filter the ones that are quoting on USDT, and then load the candles from the cache to get the data that I have here. I can reuse those and only download the things that are missing. And then get the candles batch last days and then dump those candles back in the cache. Well, this is the first notebook. Let it run. If you're running this for the first time, change this. Instead of 20, put 5. So you are like covered. And if you want to add more intervals, just add the intervals here. Let's continue with the next notebook that we are going to run here, that is trend following grid. It's inside this feature engineering. There is an improvement on the feature engineering system. In this MongoDB, now we have a collection for features. Here, for example, I call it the feature EMA trend. The idea of this system is that you can run it forever. Stuff like here, for example, I'm calculating the EMAs, then putting the direction, if it's long, short, or neutral, the intensity of the signal, and this is the range variation between the low and the high on the last 1000 records. You can scale on features independently, and in this TF pipeline you can trend following grid feature, volatility feature, machine learning feature, any feature that you imagine, you can add it as a sequential notebook to run here. What is going that to provide? A MongoDB full of features or signals generated that then you can consume from another system, and when there is a new signal, you can do whatever you want. For example, deploying a new bot. So, well, these features is here, and these signals is also registered here. This also is good for you in case that you would like to, for example, do backtesting of a system that you are going to deploy soon. You can just generate signals here and then visualize and plot. Let's see if the notebook finished. Well, here you see too many requests. This is the issue that I mentioned when you put a lot of candles. We downloaded 518 pairs in 4 minutes. You have training pairs downloaded, a number of candles, well, and so like a report. Part of what Quants-Lab provides is help on plotting. If I put candles.plot, it gives me the OHLC. If I use candles plot type equal to returns, it gives me the returns of that market. So, well, this is something that you can also explore. Well, this is the first notebook that will run in our setup of this TF pipeline. Then we're going to run this one, that is this trend following grid. Let's go to this notebook. So the first thing is to load the candles from the cache. We are going to connect to this feature storage to put our features and our signals in that MongoDB. Here we are initializing the EMA trend config. This one, EMA trend, basically uses 3 EMAs, a rolling window, a momentum window, and a decay period. The decay is to say it will put more value to the crosses of means that happened. If it crosses the mean for a long time ago, means that probably is already in the same direction for a long time, it will decay the intensity. Comparing the short EMA with the mid and the long EMA, the signal intensity uses the magnitude, momentum, acceleration, and freshness. For each candle that we have, we're going to create a feature and create a signal from the EMA trend. So if we run it, well, we run this, we can visualize a feature. We can just use this part from here. So we have these EMAs here. This shows like how to use the EMA trend indicator, and then we can save the features. Here there is like a top signals. Then it shows how to query the storage. This is basically the feature generated notebook that will run right after the data collection. We have the candles downloaded, the features generated. Now we can go to the third notebook, that is this TF pipeline notebook. So let's read this a little bit. This will allow you to design a strategy that follows a signal and does something with that signal that is going to be deploying bots, but doing it forever. Because it will get what are the current signals that I just, or the current features that I just generated. What are my active bots that are running? Is some of these bots not longer valid? And why it cannot be valid? Cannot be valid because it's a long bot and now the signal says short. The second thing will be is running for more than 6 hours and the PNL is negative, invalid, I will kill it. You will have a max number of bots or controllers, let's call it, a number of controllers available to run at the same time. And you are going to say, okay, I can have at maximum 10 controllers. distributed in maximum 3 bots. So you start and you deploy 10 bots. Perfect. The next iteration, you say, okay, from these 10 bots, these 3 are no longer valid. I will stop them. Then you will say, okay, there are other 3 that I can deploy. Yes, you can deploy them in another bot. So now you have 10 again. So basically what this notebook will provide you is like a way where you can decide what controllers to stop and what controllers to start based on the features that you are generating on a recurring basis. This is really powerful because in this case is used with this logic, but you can do whatever you want, whatever logic you want for it. What it's going to do is signal analysis. We'll fetch the top 5 long and top 5 short from the MongoDB, use the EMA trend feature with the intensity thresholds. We are going to receive the data from Telegram too. Then we are going to check all the active bots. Then we'll analyze and stop the controllers. If it's running for longer than 4 hours and also the PNL is below a threshold, we are going to stop it. If the signal direction changed, we're also going to stop it. So these are the conditions to stop controllers. Deploying a new controller, we're going to check if we are not passing the max limit. Well, this is the config. You have here some typical workflows to understand. Some important thing is you need to make sure that the API is running on localhost 8000. Configure the Telegram bot in the .m. I already have this ready. Enable notifiers. You see is Telegram. Just to show you how to use Telegram integration on Quants-Lab. Get notifier Telegram. If we run this, we need to await because it's a coroutine. Await this. You see that here I'm receiving this. We can also send a picture in Telegram. Well, then we have here the config. Uses a master account. The Hummingbot host. It will use my local host. Well, this is like how much money we're going to put to each controller. So $400 maximum allocation. We're going to deploy this try controller that is like a grid. It's in the guide that Mike just released. So you can check the guide. This long grid, this is the limit price that you see that is below the start price. And this is for a short grid. You see that the limit price is above the end price. So what we're doing here is saying that for a long, the start offset is minus 25% of the range. The end offset is 75% of the range. And the limit is minus 35. So it's like a way to define these values, but as percentages of the range that it has. How that range is calculated is using these features. I also added this range percentage to define my grid. If it's 11%, for example, for this BICO token, so will be like somewhere here. This times 75 will be 8.25%. Put this one here and this one here. So the grid, this is the end price, start price. This is the current price, start price, and end price. In case that is a long grid, right? That is what I'm doing with this config. Saying the offset of the start, the offset of the end, and the limit offset. If I run this, and then, well, we're going to connect to the features. The first thing that we're going to do is to, with the storage, get the signal with the minimum value, and then, well, mapping the long and short signals. The top long signals are in Jelly. Then here we'll says check active bots and controllers. The second one will also be the same. There are no active controllers here. The third one, that is the stop controllers, will not show anything neither. And now we need to determine the new controllers to deploy. So it will say I would like to deploy all these controllers. Now we can also visualize the opportunities. So here we'll plot. So here we are seeing what are the grids that is going to deploy. It's going to put this grid here. I need to check if it's using the actual latest data generated. So for now, the last step will be deploying the new controllers. Well, and with this last cell, it will deploy the controllers. So here it says deploying 3 new controllers, and then at the end, it will send the Telegram report. So if we go to Telegram, we will see that orchestration completed, active bots, no active bots before this run, new bots deployed, 3 bots, capital 1.2k. long jelly, short on BAT. So if we go to Binance now, we should see that we are trading already on this jelly, on EVA, on all these tokens. If we run the notebook again, the notebook now should recognize the bots that are running. So we love the signals. We have the same signals because we didn't run the features or the data collection again. If we fetch the active bots, it should now show the active bots that we have running. The winners are Jelly, 4 cents and 2 cents BAT, and the losers, EVA, is losing 0.07 cents. Analyze what controllers to stop or keep. Jelly long, keep it because the runtime is below these 0.05 hours. 3 active, no bots to archive, no controllers to stop. Determine new controllers to deploy. BAT says already running, keeping. Okay. Visualizing new opportunities, no opportunities, deploy new bots, it will not deploy new bots. And there is going to send another Telegram report that will say active bots, runtime, P&L, total performance. But well, that's everything for today. Thank you very much and see you next week. Bye bye.